Hello and welcome to helpyourmath.com. In this video, we are going to dip our pinky toe into the very large ocean that is fractions. Take a deep breath as we just talk about the definition of fractions. So pause the video and think about, what is a fraction? Most times when I ask this question to my students, I get part of a whole, or that's pretty much it. I usually just get part of a whole. And that's not wrong, okay, that's not but, and really what a fraction is it's a number. That's it. A fraction is a number, specifically a real number, or it's a value that we can represent on a number line. So if I drew this adorable number line here, and I have -1 and 0, 1 and 2, and I said, can you show me on this number line, where's the value that represents 1/2? Hopefully you would know that it's somewhere in between 0 and 1. In fact, it's exactly halfway between them. So it'd be like right here, and we could represent that fraction with a point. Really, any number we can represent with a point as long as it's a real number. So that's what a fraction is. Now, a fraction we may know has two parts. We have this top part and the bottom part. The top one is called the numerator, and the bottom one is called the denominator. Any fraction is numerator divided by denominator. So if we wanted to write it as its equivalent decimal, we would take the numerator divided by denominator. Anything else we want to do, numerator divided by denominator. Fractions that are located in the same position on the number line are called equivalent fractions. So I said that this number here is 1/2, but there's actually infinitely many equivalent fractions to 1/2, or that's values that represent that same spot on the number line. And what we're going to talk about right now is, how do we find these infinitely many other numbers that are equivalent to 1/2? So two fractions are equivalent if they simplify to the same value. We say that 1/2 is in simplest form or simplified, or sometimes you might hear reduced, because 1 and 2 are both integers. So that's an important thing. Integers, well, so 1 itself is an integer and 2 itself is an integer because neither of those contain fractions or decimals. When we write it in fraction form, clearly we've created a fraction. But 1 and 2 by themselves are called integers. They don't contain fractions or decimals. So that's part of a fraction being simplified, but also 1 and 2 don't have any common factors besides 1 itself. That's the other way of knowing that a fraction is truly in simplest form. So if we can rewrite a number, simplify it down to 1/2, then that number was equivalent to 1/2. Let's talk about finding our equivalent fractions. So I already mentioned every real number, not just fractions, but every real number has infinitely many equivalent fractions. To find an equivalent fraction of a number, we do this property, the multiplication property of equivalent fractions. So that just says, if we have this fraction, let's call it a over b, I can find any number of equivalent fractions as long as I multiply it by 1. Now, 1 might look kind of funny because we normally wouldn't say, okay, well, multiplying by 1, well, duh, that's just going to get me a over b. You're absolutely right. But what we do is we do a variation of 1. So 1 is any number divided by itself as long as the number's not 0. 1 could be 10 over 10. 1 could be 21 divided by 21, right? Because 10 divided by 10 is 1. 21 divided by 21 is 1. So instead of actually multiplying just by 1, we multiply by something that is equivalent to 1, such as 10 over 10 or 21 over 21. Generically, since I don't want to say 10 over 10 because we can multiply by anything else, I'm going to replace 1 with c over c. And then we get a times c in the numerator and b times c in the denominator, and that's an equivalent fraction. Also, what we could do instead of multiplying, since division, hear me out, is a form of multiplication, we could also divide by 1, because 17 divided by 1 is 17. 23 divided by 1 is 23. So we can apply this same property with dividing by something that is equivalent to 1. A over B, and then we could divide the numerator by C as long as we also divide the denominator by C. That would produce an equivalent fraction to what we were given. You might be asking yourself, why do we need equivalent fractions? Fair question. First, when we add or subtract fractions, we need a common denominator. Here we want to multiply fractions by that ratio, by that thing that's equivalent to 1. If I wanted to add 1/2 plus 3 over 7, I can't add these fractions as is. That's mathematically incorrect. I would need to identify what we call the least common denominator. That's just a number that both 2 and 7, they both go into, and they both go into 14. So we say 14 is the least common denominator. Sometimes we abbreviate that to the LCD. Now what I want to do is I want to write both of these fractions so that they have a denominator of 14. The 1/2, so I already have a factor of 2. I would need to multiply the 2 by 7 to get the denominator to be 14. And then for that equivalent to 1, I would also multiply the numerator. Over here with the 7, I already have that factor of 7. I need a factor of 2, so I multiply both the numerator and denominator by 2. Now my first fraction becomes 7 over 14, which again, that's equivalent to 1/2, plus my second fraction becomes 6 over 14, which again, if we simplified, would simplify back down to 3 over 7, so it's still equivalent. And when we add across the top, so it would be 7 plus 6, keep the common denominator. I have 7 14ths here, I have 6 14ths here, that gives me a total of 13 over 14. So that would be one reason why we would want to multiply by some ratio equivalent to 1. Final answers are typically expected to be written in simplest form, which is where we might want to divide the numerator and denominator by that ratio that's equivalent to 1. The example I just did, 13 over 14, is already in simplest form. We don't want to simplify it any further because that's it. That's all we can do. But let's say we had a final answer and it was 12 over 14. We say this isn't yet in simplest form because 12 and 14 have a common factor. And what we want to do is we want to divide out that common factor. 12 and 14 are both even, therefore they're both divisible by 2. So I divide by 2, and I end up with 6 over 7. So 12 over 14 is equivalent to 6 over 7, but 6 over 7 is the preferred answer because it's the one that's in simplest form. All right, in our last slide, we just want to write 2 equivalent fractions to each given number. Remember what I said? I said there are infinitely many. We're only going to list a handful for each one. I always suggest, this is a good point, pause the video and see if you can come up with some equivalent fractions. Okay, so maybe you paused and you were only successful with question 1 or maybe 1 and 2. Let's take a look. We have 1/4 and we're just going to multiply and divide equivalent numbers by whatever we want. So usually the first one we think of is 2 over 2. Great. 1/4 is equivalent to 2/8. Maybe we think of 10. Sometimes I have students who like to multiply by 10s because it's so fun. Then we get 10 over 40. That's equivalent to 1/4. I could also multiply by 3 over 3. This would give me 3 over 12. I don't even have to use the given fraction. I can use any fraction that's equivalent to it. I just want to make sure I'm coming up with something that I didn't already write. So let's take the 10 over 40. And this time, instead of multiplying, because 10 and 40 have a common factor, maybe I'll divide them both by 2. So I divide by 2, right? Because I'm allowed to divide the numerator and denominator by the same amount. Then I end up with 5 over 20. Now, could I have gotten 5 over 20 using any of the other equivalent fractions? Of course, they're all equivalent. To get it from the 1/4, I would have multiplied by 5 over 5. So these are 4 of the infinitely many possible correct answers for this first one. You might be looking at question 2 saying, whoa, 5, not a fraction. That's true, but it does have a fraction that's equivalent to it. If we're given an integer, remember those are the things that don't start out as fractions or decimals, we can always turn an integer into a fraction by putting it over 1. So 5 is the same as 5 over 1. Because remember that fraction means divide. 5 divided by 1 is 5. So that would be one equivalent fraction. What else could we do? Oh, we could multiply by, and I'm going to use this fraction now. I'm going to use the 5 over 1. I'm going to multiply by 2 over 2. And then I get 10 over 2. So 10 over 2 is equivalent to 5. Of course, 10 divided by 2 is 5. What else when we divide is equal to 5? That's another way of thinking about this. If you don't like that, if that's like weird, that's fine. You can just keep multiplying by different things. So I'm going to take 5 over 1. I'm going to multiply it by 36. Ooh, why did I choose 36? I know the denominator is 36 and the numerator would be 180. So if we checked 180 divided by 36, that should give us 5 when we do the division. And again, there are infinitely many correct answers. So just kind of listing a few in order, we would have 15 over 3, 20 over 4, 25 over 5, and so on. For the last one, so negative 2 3/7, this one's called a mixed number. A mixed number means that we have a little baby addition problem. This is like the one time where we see two numbers squished together in math, and it doesn't mean multiplication, it means addition. In this case, the negative belongs to both the 2 and the 3/7. To deal with this one, to find equivalent fractions, you're probably fine to leave it as a mixed number. So what we could do is just multiply the fraction by equivalent factors of 1, or if you wanted to, you could rewrite negative 2 3/7 as an improper fraction. I'll show both ways just so that we get that review of converting a mixed number to an improper fraction. So first I'm going to leave it just as negative 2 3/7. And when we're writing an equivalent fraction, the minus 2, the whole part, well, this is an integer actually, stays the same. I'm only going to multiply the 3/7. So maybe I multiply by, my favorite, 2 over 2. We get negative 6 over 14. And I don't think I've mentioned it yet, but you're allowed to multiply or divide both the numerator and denominator by any real number except for 0, because 0 divided by 0 is undefined. So I keep using 2 for no reason other than it's just 1 bigger than 1. But you can use whatever you want. What if I did negative 2 3/7 times, how about 6 over 6? This would give me negative 2 and 18 over 42. So these are two, again, of the infinitely many possibilities. The other option is, because I say fraction, and maybe you say, well, a mixed number doesn't have the word fraction in it, so we need to convert. Okay, to convert this mixed number to an improper fraction, so because the mixed number is negative, the improper fraction will also be negative, we take the denominator and we multiply it to the integer. So 7 times 2 is 14. Then we add the numerator. 14 plus 3 is 17. Negative 2 3/7 is equivalent to negative 17/7. And you might be asking yourself why? And that's because what we're really doing is turning negative 2 into a fraction negative 2 over 1 and getting it to have that denominator of 7. So we're using equivalent fractions to be able to convert this into an improper fraction. Now that it's in an improper fraction, we have negative 17/7. And now we can start multiplying. So maybe I want to multiply by 2 over 2. And then we would get negative 34 over 14, which should simplify to negative 17 over 7, which we could also rewrite as this minus 2 and 6/14. No, wait, sorry. If we don't simplify, we get the minus 2 and 6/14. Sorry. If we simplify, we get negative 17 over 7. If we don't simplify but rewrite it as a mixed number, it should be the same thing as negative 2 and 6/14. Got it. Okay. One more just for good measure. Let's do 4, right? 4, really we're doing 1, but we're going to multiply the numerator and denominator by 4. That'd be 34 minus 68 over 28. These have been some examples of fractions and writing equivalent fractions. Thank you for stopping by.